Chapter 13, Solutions. And again with the PowerPoint thing. Okay. I think we're all aware that you shouldn't drink seawater, right? And why would you want to anyway? It tastes nasty. If you've ever been to the ocean, it tastes bad. But, you know, you're stranded out on the ocean on a little boat and you have no water. It could be tempting. You're surrounded by water, but you've got nothing to drink. Drinking seawater actually makes you more dehydrated than not drinking anything. And we're going to investigate or look into why that is in this chapter. It's sometimes called a thirsty solution, in that the seawater will pull water out of your tissues like it is thirsty and wanting water. So what is seawater? Well, seawater is a solution. And by solution, we mean a homogeneous mixture of two or more substances. So it's a homogeneous mixture. Water is the solvent, which is the major component, and sodium chloride is the primary solute, the minor component. There are also many other things that are solutes in seawater. We're just going to consider sodium chloride as the main one. So the solvent and the solute are the parts of a solution. Every solution has to have one solvent and one or more solutes. In general, the solvent is the substance that's present in greater amount, and the solute is present in lesser amount. So nature has a tendency towards spontaneous mixing unless it's very unfavorable in terms of energy. So if we think about a big container with fresh water, pure water on one side, and salty water on the other side, separated by a barrier. If we very carefully pull that barrier out without, causing any disruptions in the liquid, and we just wait, what will happen is that the fresh water and the salt water will mix together without any assistance from anything else. It will just happen. That's spontaneous mixing. If you drink seawater, this tendency towards mixing causes a flow of solvent, water, out of the cells in your body and into the seawater. So here's a simple picture of your intestinal system, your stomach. And here we have the interior of your body, and here we have the, I guess that's in your upper intestine, right here. It's kind of funny to think about. You basically have this hole running through you, and that technically is the outside of your body, right? Inside your stomach is technically the outside of your body. Interesting. So if you've got salty water in here, the salty water draws fresh water from the cells. The cells have semi-permeable membranes which allow water to pass through, which is how you can absorb the water that you drink, water going in the other way. But the seawater will cause the water to come out. So we have a dilute solution here, less solute, and a more concentrated solution here, higher solute concentration. And so the water will flow towards the more concentrated solution. In terms of spontaneous mixing, we can think of nature as trying to make things equal, right? And, you pour water down a hill and it's going to go down and become level, right? It's not going to have lumps and bumps in it. Everything's tried to be level. So one way to remember which direction this flow is that the water is thinking, I want to make everything the same concentration. That's what happens here. We end up with everything being uniform in concentration. Here, there are membranes that prevent the physical mixing because the solute particles are too large to pass through the membranes. So the water's the only thing that can move. So there's a little bit of salt over here, and there's a lot of salt over here. So if the water moves towards the concentrated solution, it can dilute that, and by leaving the dilute solution, it causes that to become more concentrated. And the water will flow in that direction until the concentration of solute is the same on both sides. Anybody have any questions?